All right, here we're going to really look at the connection between the graph of the derivative of the function and the graph of the function itself. So in this particular problem, we're given, this is the graph of the derivative of f, and from this graph, we want to sketch what the graph of the function y equals f of x looks like. Now, remember that there's an entire class of functions that have the same derivative that differ by a constant. So we're simply going to be looking for one possible graph whose derivative would match the given graph. So let's remember that we can use the derivative f prime of x can be used to find the slopes of tangent lines to the graph of f. And that's how I'm going to take advantage of having this graph of the derivative to get the original function f. So I actually want to look at a sign chart here. I'm used to, graphing functions given the sign chart of the derivative. So let's take a look here. If you look at this derivative, you'll notice that the derivative is equal to 0 at 1. Okay, so at 1 it's equal to 0, and it's equal to 0 again at 4. All right. Now until I get to 1, the derivative is entirely above the x-axis, so the derivative is positive. Between 1 and 4 it drops below the x-axis, so our derivative is negative. And once I get past 4, it's once again above. All right. So I'm looking for a function whose derivative, slope of the tangent line, is positive until I get to 1, and then I have a slope that's 0. So I have, either a hill or a valley of some sort, or possibly a cubic shape. Then the slope goes negative, it's 0, and it's positive again. All right, so let's see if we can come up with a graph that would have this for its slopes of its tangent lines. All right. So we're starting just here a little bit to the left of 0. And I don't know where to start. That's that constant that can be added on to my function and won't change the derivative. So I'm just going to pick a place to start here. Okay? And I want to start with my derivative being positive and then heading toward a derivative of 0. Okay, so positive tangent line means my graph is increasing for a while, and when I get to 1, it's going to level off. Okay, so something like that. All right, here's 4. Okay, now between 1 and 4, I should have a derivative that's negative, and then when I get to 4, let me just say I'm going to put the point for 4 right there. It should level off again. Okay. So it's got to do something like this. And then past 4, the derivative is positive, the slope of the tangent line is positive, my graph should be increasing once again. So this is one possible function f of x that would have this graph as the graph of its derivative. So we have a function that's increasing until I get to 1, decreasing and then until I get to 4 where it levels off again, and increasing after that. Now if we wanted to, we could go even farther and think about the second derivative, but we can get enough information just from looking at the graph of the derivative to get a possible graph for the original function.